Now in the question 4, shade the following regions on separate Venn diagrams. Here we have a rectangle that shows the universal set eta, and inside it we have two overlapping circles that represents the set K and L. What is meant by overlapping sets? It means there are some elements that are common to both the sets K and L. So in the part 1, we have to find out K intersection L. So for this, first we will identify the region for the set K only. So now we will draw a rectangle on a separate Venn diagram that represents the set eta, a universal set. And inside it, we will draw two overlapping circles, one for the set K and the other for the set L. Now we will shade the region for the set K only with red color. So the area shaded in red represents the set K only. Now in the second Venn diagram, we will again draw a rectangle that represents the set eta, and inside it, we will draw two circles, two overlapping circles that represents the set K and L. And now we will shade the region for the set L with black color. This black shaded region represents the set L only. But what was our aim? We have to find out the K intersection L. So it means we have to find out the region that is common in the first and second Venn diagram. So now we have to identify that region first. So the region that is common the first and second Venn diagram is the region shaded in red, or we can call it overlapping region also. It's overlapping region. So the third Venn diagram shows K intersection L. Now in the part 2, we have to find out the K union L. So for this, first we will draw a rectangle that represents the universal set eta, and inside it we have two overlapping circles that represents the set K and L respectively. Now we will identify the region for the set K only in the first Venn diagram, and we shade that region with black color. Now in the second Venn diagram, we have to color the region for the set L only. So here we have two overlapping circles, similarly for the set K and L, as we have drawn in the first Venn diagram. And now we will shade the region for the set L with red color. Now we will put all the shaded regions of the first and second Venn diagram in our resulting Venn diagram. So for our final Venn diagram, or the third, last but not the least, we have a rectangle and two overlapping circles that representing sets K and L. Now we will shade the region for K union L with black color. We have do what? We have just put the shaded regions of first and second Venn diagram together in the third Venn diagram. So this is a Venn diagram representation of K union L. Now in the third part, we have to find out the K union L Hall complement. So for this, we have to identify the region for the K union L Hall complement. In other words, we can say that the region that belongs to the set eta but does not belong to the set K union L. So for this, first we will draw a rectangle that represents the set eta, a universal set. Now inside it, we will draw two overlapping circles representing the sets K and L respectively. And now we will shade the region for the set eta, excluding the region for K union L. Since in the second part, we have seen the region that we are excluding now is the region for the K union L. So this is the Venn diagram representation for the K union L Hall complement. This is the region that belongs to the set eta but does not belong to the set K union L. Now in the question 5, we have to describe the shaded region in each of the following Venn diagrams in the set notation. So in the part A, we have a universal set eta and two overlapping sets A and B. So the shaded region belongs to the set A. So in the set notation, it shows the set A. So here we have set A in part A. Now in part B, the shaded region belongs to the set B. So in the set notation, it shows the set B. In the part C, the shaded region belongs to the overlapping region of the sets A and B. So it shows A intersection B in set notation. Now in the part D, we can see that the shaded region belongs to both the sets A and B. So it shows A union B in the set notation. So set D shows A union B. Now for part E, we can see that the shaded region belongs to the set eta and the set B only. Or in other words, it excludes the set A. So it shows A complement in the set notation. In the final part F, the shaded region belongs to the set eta and the set A only. Or in other words, it excludes the set B. So it shows B complement in the set notation. So first we will read the statement of the problem. So here we have 253 participants were asked to complete a survey about their fruit preferences. 179 of them like durian, while 43 of them like neither durian nor apple. How many participants of the survey like apple but not durian? We will divide the solution of the problem in different stages. So in the first part, or in the first stage, we will understand the problem. So we will understand the problem. In order to understand the problem, we will see what information is given and what is not. So first, we will see what is given. Total number of participants in survey about fruit preferences. Number of participants who like durian. And the number of participants who like neither of the two fruits. And the number of participants who neither likes the of the two fruits. Now we will have a look what is not given. So now we will see what is not given. Number of participants who only like durian. Number of participants who only like durian. Number of people who only like apple. Now, what are we supposed to find? Now, what are we supposed to find? The number of people who like apple but not durian. Number of people who like apple but not durian. Now in the step 2, we will think of a plan. To find the number of participants who like apple but not durian, since we want to find the number of people who like apple but not durian, can't we use a Venn diagram to help us to visualize and find the information easily? Yes, we can. So draw a Venn diagram to represent the set. Now in the step 3, we will carry out a plan. So for this, let D and A be the set of people who like durian and apple, respectively. So now we will draw a rectangle that represents the universal set eta. And inside it, we will draw two overlapping circles that represents the set D and A respectively, the sets of people who like durian and apple respectively. Why these two sets overlap? Just because these are the set of people who like fruits, because durian and apple both are fruits. So that's why there are something in common between these two sets, D and A. And the number of people who like durian is already given in the question, and that is 179. So we will write down here, and NOF D is equals to 179. And since we have to find out the number of people who likes only apple but not durian, so mathematically we will write down like D complement intersection A. So we have to find out the number of elements in the sets D complement intersection A. Now to find out the complement intersection A with the help of Venn diagram, we will draw a rectangle and draw two overlapping circles inside it that represents the set D and A respectively. And now first, we will identify the region for the D complement only. So for this, we will exclude the set D and shaded the remaining region in the Venn diagram. So we will shade our required region for D complement with red color. So the Venn diagram for the D complement will be look like this. Now we will draw another Venn diagram. To find out the region for the set A. So for this, we will color the region for the set A with black color. Now to find out D complement intersection A, we have to see the regions that are common in the first Venn diagram and the second Venn diagram. So for this, first we will draw a rectangle for the universal set eta And inside it, we will draw two overlapping circles for the sets D and A. And now we will identify the common region that is present in the first and second Venn diagrams. So this is the region that is present in the both Venn diagrams. So this is the Venn diagram for D complement intersection A. And since we want to find out the number of people who like apple but not durian, is equals to n of D complement intersection A. So now we will write down the information that is given in the statement of the problem. The number of elements in the universal set eta is equals to 253, just because this is the total number of participants in the survey. And the n of D, the number of people who like durian, is equals to 179. And the number of people who like neither apple nor durian, it means D complement intersection A complement is equals to 43. Now we will find out the number of elements in the D complement intersection A is equals to number of elements minus number of elements in the universal set eta minus number of elements in the set D minus number of elements in the set D complement intersection A complement. In other words, the number of people who like neither durian nor apple. So the number of elements in the universal set is 253. The number of elements in the set D is 179. And the number of elements in the set D complement intersection A complement is 43. So after subtraction, we will get 31. So the number of people who like apple but not durian is equals to 31. So the number of elements in the set D complement intersection A is equals to 31. Now in the step 4, we will look back to check that our solution is correct or not. So the number of people who like durian is equals to, so the number of people who like durian is equals to 179. The number of people who like neither apple nor durian, number of people who like neither apple nor durian is equals to 43. And the number of people who only like apple, the number of people who only like apple is equals to 31. Now the total number of people will be equals to 179 plus 43 plus 31, and it will be add up to 253. Are there other ways to solve the problem? For example, do we really need to do step 3? Step 3 is not necessary to solve the problem. Once we determine that there are 31 people who only like apple, we can find number of people who like neither of the two fruits by doing this, just like we have done. We have subtracted the number of people who like durian and the number of people who like apples only from the total number of participants. Then we will get the number of people who like neither durian nor apple, and that is equals to 43. So however, we complete the Venn diagram for the purpose of illustration. So our solution is ended up here. Now first we will see the statement of the question 7. In a class of 38 students, 19 students have traveled to Malaysia while 4 students have neither traveled to Malaysia nor Indonesia. Find the number of students in the class who have traveled to Indonesia but not Malaysia. To solve the problem, we will divide the solution of the problem in the different stages. So in the stage 1, we will understand the problem. So first we will see what is given. Total number of students who travel to Malaysia. First, total number of students. Secondly, number of students who traveled to Malaysia. Number of students who traveled to neither Malaysia nor Indonesia. Now we will see what is not given. Number of students who only traveled to Malaysia. Number of students who only traveled to Indonesia. Now the next thing is, what are we supposed to find out? What are we supposed to find out? Number of students who traveled to Indonesia, but not Malaysia. Now in that stage 2, think of a plan. To find the number of students who travels to Indonesia but not Malaysia, since we want to find the number of students who traveled to Indonesia but not Malaysia. So can we use a Venn diagram to help us and find the information easily? Yes, we can. Yes, we can draw a Venn diagram to represent the sets. And now in the stage 3, carry out the plan. Let M and I be the set of students who traveled to Malaysia. And Indonesia, respectively. So now we will draw a Venn diagram. First, we will draw a rectangle that represents the set eta. Inside it, we will draw two overlapping circles that represents the sets M and I respectively. Since the number of students who traveled to Malaysia is given in the question and that are equals to 19, so N of M is equals to 19. And we have to find out the students who traveled to Indonesia but not Malaysia. So M complement intersection I is our requirement to find. So now we will divide over operation M complement intersection I in different Venn diagrams. So for the first Venn diagram, we will draw a rectangle for the universal set eta. Inside it, we will draw two circles to represent the sets M and I respectively. Now for the M prime or M complement, we will shade the region excluding the set M with red color. So the region shaded in red represents the M complement. Now in the next Venn diagram, we want to find out the region for the set I. So for this, we will shade the region of the set I with black color. Now in the third Venn diagram, we will again draw a rectangle to represent the universal set eta. Inside it, we will draw two overlapping circles for the sets M and I respectively. And this Venn diagram represents M complement intersection I. So to identify the region for M complement intersection I, we will see the region in the first and second Venn diagrams that is common in both the diagrams. So the region shaded in I represents the required region or the common region that shows M complement intersection. Now we will take the information from the question. Since the number of elements in the set eta is already given, so the N of eta is equals to 38. The number of students who travel to Malaysia is equals to 19, and the students who travel to neither Indonesia nor Malaysia is equals to 4. So we can easily find out the number of students who traveled to Indonesia but not Malaysia. And it can be found out by using subtracting the number of elements of the set M and the number of elements of the set M complement intersection I complement from the number of elements of the set eta. So the number of elements in the set eta is 38. The number of elements in the set M is 90, and the number of elements in the set M complement intersection I complement is 4. Now in the stage 4, we look back. So the number of students who travel to Malaysia is equals to 19. Number of students who traveled to neither Malaysia nor Indonesia is equals to 4. And the number of students who traveled, who only traveled to Indonesia is equals to 15. So the total number of students is equals to 19 plus 4 plus 15, and it will be add up to 38. So this shows that our question is correct. By doing this, (38) minus 15 minus 19, and it will give us 4. However, we complete the one diagram for the purpose of illustration only. So here the problem ends.